Namaskar, welcome back. So, this was the last slide we were talking about the depositional coastal landforms. Let's see further what we have, and then we will also at the end I will try to see the what are the what corals have to tell us about the land level change or the sea level change. Okay. So, mostly this is what we have been discussing about, that we have various landforms, and in mostly the depositional landforms uh, are composed of loose sand and pebbles, okay, and they will produce a very extensive flat uh, landform, that is your beaches. Okay. So, these are the example of beach from Andaman, and as well as what you see here is the sea cliff. Okay. So, you have erosional as well as the depositional landform. So, this will become your depositional landform. Now, coming to another few more depositional landforms, as we have previously discussed, that these are spits are mostly because of the lateral drift which will be formed. Then you have bars and mouth bars, lagoons if they are closed, and tambola if you are having uh, the the connected island because of the near shore island, we can say, that grows. Okay. So, this gives a complete a picture of different landforms. So, you have spit, and if they get connected, okay, then you will have formation of the lagoons. Okay. And then tambola is something like this, which has been connected from the by the sandbar or some rocky portion, that will they are termed as tambolas. Okay. So, this is a typical example of spit which has been forming in the coastal region, and this is your tumbolo. Okay. Further, if we see, then we will have, like, if they cover up the part here, then that will form a lagoon. Okay. And that in this we have discussed about that this is because of the lateral drift or longshore drift. Okay. Now, another important landform here is the lagoon, okay, which we were able to see the formation of. This is a typical lagoon from Car Nicobar, okay, enclosed and protected by barrier beaches, or we also call this as an sea beach ridges. Okay. Now, in this environment, we will have fresh water coming in, and as well as the you will have the during higher high tides, you will have the water coming from the ocean side also. Okay. Then typical tropical mangroves, and in some cases this mangroves are also like act as in protective barriers to the high energy ocean waves or sea waves, you can say. And in some locations during 2004 tsunamis, wherever we were having this mangroves, that those areas where like less damage was been experienced there. And then tidal flats. Okay, tidal flats can be subdivided into three. Okay, that is your supratidal, okay, which is away from the ocean. If you are coming closer, then intertidal, and then you have the subtidal. Okay. And this can be identified if you want to look at in the normal conditions. Of course, based on the topography, you can also justify that, but at the same time, if you see a sort of the sediment sections, okay, then also you can identify that whether this area was in the past in the intertidal zone or not, and that what we call a sort of an waved up flazer deposits. Okay, you will see something like this. Okay, so these are termed as flazer deposits. And then you have beach ridges or the barriers which have been formed because of the deposition, and sometimes these are also been resulted because of the uplift of the area. And the shallow lagoons are also we term that as in back marsh areas. And this is the process of what we were talking about, that if the spit gets connected, then the inner side towards the land will form a sort of an bay area or lagoon. Now coming to the corals, okay, other than your mangroves in the tropical coasts, okay, the corals are indicators of sea level fall and rise, okay, because they survive at the uh, nominal sea level, or we can say that they will survive at the mean sea level of that. So lower tide, they will always seen that they are inundated, okay, and if they are uplifted or if they are exposed, then they will die. That portion of the coral will die, okay. So while I'm taking back to the Andaman Islands, where we were able to see beautiful coral atolls, okay. So those corals were been like exposed. So before going to that, let us see that how coral grows. Okay, coral usually grow uh, in the upward direction, that is towards the and then that remains always in at the mean sea level. Okay, so it will grow in the upward direction as well as lateral. Okay, so this is and they will remain at the tidal levels. Okay. Suppose there is an sort of an they are exposed, okay, then they will not grow up, but they will keep growing laterally, okay. So once at load level tide, corals can only grow sideways, okay. So they will not grow above the tidal levels, okay. They will not go not okay. So suppose there is like you talk about that when island sinks, okay, then what will happen is that coral continue to grow. So this portion will start growing, and then laterally you will see. So first one in the second slide we saw that this was the sea, this was the level. Now it has gone up. Okay. So that means what has happened here is that you have a area has gone down. Okay, because it has subsided, or the sea level has gone up. Okay, so either we say subsidence or we say the sea level rise. So when the island pops up, okay, this is the case of uplift. Okay. Uplift, or you have sea level fall. So the previous sea level was this one, hence it allowed the coral to grow up as well as laterally. So this portion has been developed at that point of time. Okay. So this was the previous one. This was the previous one. Now, because this portion has been exposed, okay, it will not grow up as well as lateral growth will stop. Okay. But at the same time, this portion will start growing. So when the island pops up, okay, during an earthquake, or you can say the sea level fall, okay, the upper part of the coral dies. So this portion, the coral will die actually. But the lower part is still under the low tide conditions, okay, so that will grow. So this type of uh, coral are typically like you can see a sort of this shape, okay, and these are we term this as an hat shape corals. Okay. Now, this is a photograph which was been taken immediately after 2004 Sumatra Andaman earthquake, where we can see the these were exposed actually. Okay, these corals were exposed, and this is from North Reef Island, which was uplifted by about 1.3 meters. So, the corals which were been growing here were like it in if in future it remains as it is, then it will the corals will die. Okay. So, another example of the uplift, as we were discussing about the coastline which are exposed. Okay. So, this was the before the earthquake, this was the low tide areas, okay, low tide, and of course, this will be the high tide. But now the low tide is sitting here, and this is after 2004 earthquake. So, again this area has been uplifted, and this is from the west coast of Andaman Island. Another example of subsidence, okay, because if you look at the Andaman Islands, okay, then eastern side subsided, whereas the western side was uplifted. But if you go further down here, then you have Car Nicobar, and this is the photograph of Car Nicobar, this one. So, Car Nicobar area subsided, it was close to the, so this area experienced subsidence, and the subsidence was up to order of 1.5 to 2 meters. This part we will discuss when we are talking about the tsunamis and all that. Okay. Now, this is very good example of the processes which will change over the time. Okay. So, the previous photograph we took in 2005, okay, because earthquake was in 2004. So, after that we took this photograph in 2005, where we saw that the inspection bungalow of army is sitting in waters. Okay. When we talked to the survivors, of course, this area had a massive damage and all that. They suggested that they used to have a beach of almost like 100-meter wide. Beach was there because this island is not very, in terms of the elevation, not very high. So, they used to have beach here. Now, beach process, as I explained, that you will have like the waves coming in and coming down, that is swash and backwash. Okay. So, now since this area has subsided, so for example, this is the area we are having. Now, if this subsides, okay, and so earlier the sea level was here. Now, it suppose it subsides, then what you see is that this was the previous topography, and then now the sea level has risen up, okay, because of the subsidence. Okay. So, process has started operating over here. Okay. But in case of the uplift, it will be totally opposite. The process will be, now the beach process will be somewhere over here in this area. So, what we saw after a couple of years, and that was almost like we were there in after 6-7 years, and this was in 2011. We saw that the area over here we saw the formation of beach ridge in this area. Okay. So, the tectonics or the tectonic activity affected the area and the processes. Okay. Yeah, 2009-10, sorry, this is around that period. Okay. Also, in some areas we were able to see the subsidence, as I told, the uh, eastern portion of Andaman Island, and this photograph is from Port Blair. Port Blair is, if you see the island, Port Blair is located somewhere over here in this. Okay, so this all area also subsided almost by 1 meter. So this was the situation after 2004 earthquake. Another example of the subsidence where you had this one was the previous beach, okay, before 2004, and this was the higher water level, high water level or high tide level, okay, before 2004. But now it has moved to this one, okay, present day water. So this portion is under erosion because the area has gone down and the sea level has reached and moved inland. Okay, so the erosion is been moved inlandward. Okay, so this is a present day beach you are having, and this one is your beach ridge, because no one will grow this coconuts trees on in the erosional portion. Okay, so this is another very good example which we were able to encounter after 2004 earthquake. Now, as I told that we will be discussing this in detail, but then quickly I just want to show that how we try to see the signatures of paleo earthquakes or ancient earthquakes in stratigraphy. Of course, we try to look at the landforms, but even in the stratigraphy, because if there is sudden change in the environment, that can be picked up from the stratigraphic near coastal stratigraphy we can do. So this work we did close to the Port Blair. This is the Port Blair is here. Okay, and again, as I told that this area was subsided almost by 1 meter, close to 1 meter. So we thought that whether similar type of events have occurred in the past or not, that was the idea behind this. Okay. So this is the area known as Meetha Khadi, which is almost like around 20 kilometers from Port Blair, and we looked at in very ideal condition because the bay areas, there is a bay here, so this is in the bay area here, okay, which is known as flat bay. So this bay areas are very much like, you can say, ideal conditions for preservations of such events and tsunamis also. Okay, and of course we also saw some signatures of tsunami waves and related destruction. Okay, that I'll talk maybe later when we are talking. So we did a very detailed survey over here. We identified, we took the topographic profile, and we were able to see that there is a beach ridge here and then the back marsh area. And again, this area was subsided during 2004 earthquake, and we wanted to see that if there are any signatures of similar type of events in the past or not. Okay. So we used geoslices, and instead of, and couple of places we also dig trenches. Okay, and then what the most interesting part was that we were able to see a sort of uh, this massive silty clay, and along with so that was an indication of subsidence. Okay, because such deposits will be seen deposited in a very calm environment. So that was the area, because area was subsided. Okay, and then we have the coarser deposits on the top, and based on the ages we were able to fix up that there was a similar type of event of subsidence, okay, during 1600 AD. So these are these few examples from there where we saw the clear-cut indications of inclined stratification towards the land. Okay, So that indicates that, so there is, this side is the sea facing and section, and this is what we see in inclined stratification. So these are related to the, or deposited during the high energy, under the high energy conditions. Okay. Hence, this was, we interpreted that this is in tsunami deposits. Okay. And then another example was that we had a chaotic layer that is muddy, and it was having a very sharp contact. Okay. So erosive contacts. So those things we were able to identify. I'll discuss this when we are talking about in tsunamis and all that. And further deeper part, we were able to see the dead, okay, rhizomes, which were preserved. So this is because of the sudden area going down, and on the top we have a very fine massive clay unit. Okay. So this clay unit indicates that this was deposited during a calm environment, that is at the deeper portion of the ocean. Not very deep, but yes, comparatively deeper. So this type of indicators we use to identify the tectonic events. Okay. And these were sudden, because if there is a climate change related sea level rise or fall, then this type of contacts, the sharp contacts, we will not, boundaries we will not be able to see, because it will be gradual. Climate cannot have instants or sudden change. Okay. It will have gradual change. So those things we were able to see in Andaman Islands. Okay. So further, we also looked at some area further south, and we were fortunate enough that we were able to gather this images, okay, from Google Earth before, what was the landscape and what happened after. Okay. So these were the two sites. Again, we examined further south of the Port Blair. The first one was from here, and then this area is somewhere here. Okay. So what we saw was quite dramatic change, okay, in this region. And then we also had an evidence of the subsidence on the way when we were moving to that side, a clear-cut indication of the subsidence. Okay. So this was the wall along the coastal road before 2004, and then this is the present one. Okay. So the area subsided. That clearly indicate that the area subsided, and this was the height of the tsunami wave and inundation during 2004. So you can see here that because of the subsidence, this is the before, the shop is before 2004, and this is after. So as I told that we were able to look at some very dramatic change, land level change here. This was April 2004 image, okay, and this is 2006. What it affected areas, okay, were affected, because and subsidence was almost like one, because this one April, the event was in December. So this is before the earthquake. So what we see here is that you have a beach, okay, and then a channel over here. You can also, in the next photographs, you will be able to see that channel changes. Okay. So channel morphology changed, okay, and then because this area was subsided almost like around 1 meter, but later on we measured it was around like half a meter or so in the subsidence was there. But the processes has moved inland. Okay. So this was the previous beach. Okay. older one, and this is now the present one. Okay. So, we will stop here, and then in the next class, whatever is left out in coastal landforms, we will discuss that and then move to the new topic. Till then, thank you so much. Namaskar.